Hello everyone,
My name is Nicholas,
my name is Dominic.
and today we will be sharing a very special chemistry video for everyone on the platform.
For this video, we will be talking about synthetic rubber, its uses, and its chemistry.
This video is done with the help and motivation from our chemistry teacher, Ms. Mariana. Please subscribe to her channel for more chemistry-related content. What is synthetic rubber? Synthetic rubber is a polymer synthesized from petroleum byproducts, which is very flexible, heat-resistant, and has high durability. It is now one of the most commonly used materials in the modern era, such as in vehicle tires, gym flooring, carpets, treadmills, conveyor belts, and even cables, which we use in our daily life to connect electrical sources to our devices we use every day, like the television. Even in the sports industry, specifically basketball, rubber is used to make basketballs and shoe soles, mainly due to its elasticity and frictional resistance. But here comes the next question: how is synthetic rubber actually made? We'll start all the way back from the fractional distillation of crude oil. The oil is distilled under very high heat into 8 parts like shown: refinery gas, gasoline, naphtha, kerosene, and etc. But for now, we'll focus on naphtha to filtrate, contributing to the production of rubber. The naphtha is then combined with natural gases, which then eventually react to form a few compounds called monomers, a single unit of thousands of themselves in a single molecule of the rubber itself.
One common example of synthetic rubber is neoprene, which contributes most to the production of swimsuits. Its monomer is called chloroprene, with a structure consisting of carbon atoms, hydrogen atoms, and one chlorine atom. It undergoes additional polymerization, denoted by the letter N, to form long chains of molecules of polychloropene.
I'll try to explain addition polymerization in more detail with 3 monomer units. Firstly, the pi bonds, or you can say one of the double bonds, in the monomers break apart within suitable optimal reaction conditions. Next, a new pi bond forms within the untouched single bond, and the new structure links up with thousands of other identical copies, chaining themselves, therefore forming new rubber molecules.
Another widely common type of synthetic rubber is called styrene butadiene rubber, or abbreviated SSBR. In this reaction, we have 2 monomers, 1,3 butadiene, which is a colorless gas, and styrene, a colorless flammable liquid. It undergoes polymerization with the presence of sodium and heat to form a polymer, where the single unit is a fusion of both monomers, called butadiene styrene copolymer, which is then remanufactured to create the useful needs, such as tires, shoe soles, food container sealings, and more.
Are there any differences between synthetic and natural rubber? Natural rubber, in contrast to synthetic rubber, is produced naturally from certain trees, such as the Brazilian tree Hevea brasiliensis. Natural rubber is also known to be biodegradable, have higher tensile strength, higher tear resistance, and lower odor. Some uses of natural rubber include erasers, balloons, some clothing, surgical gloves, and even toys. But behind all of that, just like synthetic rubber, natural rubber also has its own monomer. This time, it's a 4-carbon chain with 2 pairs of double bonds and a methyl group called isoprene. It is known that isoprene polymerizes in the same way chloroprene does, by addition polymerization. But there is another subtle feature that both of these frequently used materials share in common, which isn't as much known of, and that is that both of these rubber types can have their properties improved via a process called vulcanization.
Vulcanization. What is it? It is when sulfur is added into rubber and then heated up, and its product is vulcanized rubber, which has an increase in its durability. This made the demand of rubber increase a long time ago and is still used in our everyday lives, such as car tires or even your shoes. Neoprene is a type of synthetic rubber that has better resistance to higher temperature. Add sulfur and heat it up for much better resistance. To speed up this process, you can use accelerants such as MgO, ZNO, or PB304. The benefits to vulcanized rubber is that it has stronger durability, low water absorption, high resistance to oxidation, and much more.
During the process, disulfide crosslinks are formed between the rubber molecules, consisting of 2 sulfur atoms in each link. This is what increases the stability and elasticity of the polymer.
This is the polymer molecules and the disulfide bridge of the finished product. Vulcanized rubber is then restructured and processed for the world to use. And since it is very efficient, it is the reason why rubber plays a huge role in our mechanical industry. Without rubber, technology wouldn't be as advanced as it is today. Hopefully in the future, rubber can contribute to more aspects of life and it can be recycled further without harming the environment. So that is it for the video.
And thank you for listening.